about power plant engineering. Namaste friends. In previous lecture, I explained various travelling grate stokers. As is known, these are used for proper combustion of fuel. In this lecture, I will take up pulverized fuel firing. Fuel, mainly coal, is used in pulverized form. Therefore, it is also referred to as pulverized coal firing. As is known, coal in pulverized form is in powdered state. Ideally, bituminous coal should be pulverized to 80% 200 mesh size. This means 80% of coal should pass through a mesh of 200 size. 0.07 millimeter is the diameter of holes in a mesh of 200 size. In pulverized form, coal particles are of very small size, become more convenient due to their small size. A stream of air carries them to furnace. High temperature of flame from burner causes almost spontaneous combustion of these particles. The stream of air that carries coal particles is turbulent in nature. As it comes to a air preheater, it is at higher temperature. About 70% of air from air preheater is supplied as secondary air. Remaining 30% is supplied as primary air. The primary air is supplied in pulverizer and secondary air goes to furnace. As excess air is supplied, it provides sufficient oxygen for combustion. This causes quick and complete combustion of coal. As we are all aware, complete combustion means efficient combustion. The major portion of ash formed falls on travelling grate. From there, it is transferred to ash bin. Remaining portion of ash is taken away by air stream. Ash formed from the combustion of pulverized coal is in the form of very fine particles. This is known as fly ash. Because of its particle size, it mixes with atmospheric air and is health hazard. Therefore, it is highly essential to dispose it off with responsibility. It may be mentioned here that coal is still the major fuel used in thermal power plants. Pulverized fuel firing. In almost all the thermal power plants, pulverized fuel firing is used. As already mentioned, it facilitates efficient combustion, making operation cost effective. Main components of pulverized fuel firing system are crusher, magnetic separator, coal dryer and bunker. Crusher. Crushers are used to reduce the size of coal at initial stage. Coal that comes from mines is in the form of big chunks. These are reduced to suitable size with the help of crusher. Details of crusher has already been explained in one of the previous lectures. Magnetic separator. Magnetic separator is used to remove tramp or stray iron particles from coal. Coal that arrives from mines has iron particles. These particles cannot be allowed to remain in coal. The obvious reason is that even a small iron particle may go to hearth, where it will melt and spoil the components of travelling grate. Also, it can damage the burners in furnace. Suspended electro-magnet separator. It is a commonly used magnetic separator, also known as inline magnetic separator. A strong electromagnet separates iron particles from coal. Being a strong magnet, it effectively removes the iron particles. The electromagnet is suspended above the main conveyor belt carrying coal, and therefore the name suspended electromagnet separator. Referring to diagram for constructional details and working, a magnetic separator has a strong electromagnet for effective separation of iron particles. As may be seen in the diagram, coal with iron particles moves over a belt and pulley arrangement shown on lower side. It may be noticed that belt and pulley arrangement is slightly inclined. This facilitates the downfall of coal as shown on right hand side. Above it there is an electromagnet which is quite big in size. It can produce a magnetic field strong enough to withdraw iron particles from coal. Iron particles stick to the self-cleaning belt due to magnetic force. As the belt moves rightwards and iron particles come out of magnetic field, these fall down. Self-cleaning belt moves over 4 pulleys as shown. Iron particles fall down before self-cleaning belt starts moving upwards on right hand side. Downward streams of coal and iron particles are separated by a reasonable distance. Downward stream of iron particles has not been shown in the diagram. Coal dryer. The pulverized coal coming out of magnetic separator may not be dry. This is because the coal is passed through the washery to remove the dust particles. Another reason is that it may be lying outside during rains. It is essential to dry it before storing in bunker. Drying of coal is done by exposing it to hot air. Hot air comes from air preheater. Bunker. Bunker stores pulverized coal. It is essential that coal supply to hearth of the furnace is not interrupted. Bunker should be of such a capacity that supply of coal is uninterrupted. It should also take up the variation in the requirement of coal with variation in load. Pulverized coal firing system has 2 variants. These variants are unit or direct system and bin or central system. The unit or direct system has individual scales and pulverizers for each burner. Bin or central system has only one scale and pulverizer for all the burners. In addition to these, there is a central bin and feeder. Another important difference is that unit or direct system requires higher capacity as compared to bin or central system. Unit or direct system. This system has got simple layout. Referring to diagram that shows different components of system as blocks. First, raw coal is collected in main bunker as shown on left hand side of the diagram. From here, the coal moves to crusher. As we are aware, smaller pieces of coal can be pulverized easily. From here, smaller pieces of coal move to magnetic separator. As is known, it takes away iron pieces that may be present in coal. Magnetic force causes this separation. Next comes the coal dryer. The coal may become wet due to weather conditions and in washery, where it is washed to remove dust and other insoluble constituents. In dryer, it is dried. Outgoing steam from boiler is used for this purpose. Dry coal from dryer is stored in bunker. This bunker can store sufficient quantity of coal needed for continuous combustion in furnace. We are assuming that furnace has got 3 burners, B1, B2 and B3. The number of burners depend upon the plant capacity. It also depends upon requirement of steam. Accordingly, in this system, there are 3 scales S1, S2 and S3 and 3 pulverizers P1, P2 and P3. Scale is an important component. It is essential to control the quantity of coal being fed. Therefore, coal is weighed before it is sent to pulverizer. In pulverizer, coal is converted into powdered form as explained earlier. This pulverized coal is sent to respective burners where it burns. Bin or central system. This system has got few additional components other than explained in unit or direct system. These are central bin and feeder. To know constructional details and working, I refer to diagram. That is again a block diagram. As may be noticed, it has bin where raw coal is stored. Next to it are crusher, magnetic separator, coal dryer and coal bunker. All these components are same as explained in unit or direct system. In this system too, there are 3 burners B1, B2 and B3 in furnace. It may be noticed that in this system there is a single scale. The coal that is weighed here is uniformly distributed and supplied. Pulverizer is also common to all the burners. Next, there is central bin that accommodates processed pulverized coal. This coal is then fed to feeder as shown. From feeder, it is fed to burners B1, B2 and B3. Unit or direct system has a simple and economical layout. It also has simple transport system for coal. It gives direct control to combustion. Bin or central system can cope up with load variation in plant. In this system, quantity of fuel and air can be controlled separately. Here, burner operation does not depend upon coal preparation. Though power consumption is low, it is an expensive system as capital, operational and maintenance cost is high. Also, it requires more space. Pulverized fuel firing, as explained, consists of pulverizer and delivery system. The feeding system used is indirect system. It has bin for storage as already explained. Therefore, these are also known as bin or storage systems. It does not find application in modern thermal power plant. Modern thermal power plants these days have direct firing system. It effectively permits continuous operation and also takes into account the variation of load on the plant. The change here has also taken place due to requirement of industry. Direct firing system. Here, pulverized coal is directly fed to burners in the furnace. Primary air required for combustion acts as carrier of coal. In this process, risk of spontaneous combustion is minimized. To understand the constructional details and working, let me refer to the diagram, where different components have been shown as blocks. On the top left-hand side, there is bunker to store raw coal. It is transferred to feeder on lower side, from where it is fed to pulverizer. Feeder is capable of regulating the amount of coal precisely into the pulverizer. This enables to fulfill the demand of steam according to load on the plant. Air fan 1 at the bottom supplies primary air that moves upwards to pulverizer. Air supplied by fan is at high temperature. This enables drying of pulverized coal coming out of pulverizer. Air with pulverized coal moves to ejector that has nozzle at the end as shown. The nozzle sprays coal and air inside the furnace. Coal burns immediately as it enters the furnace. Air fan 2 on right bottom supplies air that is transferred to furnace. This acts as secondary air for the process of combustion. Only one burner has been shown in the diagram, but their number can be increased depending upon the requirement. This system is safe as pulverized coal is not stored. Dry hot temperature due to weather and oxygen available in atmosphere may cause burning of coal spontaneously. This situation is avoided here. It provides instantaneous control on firing rate. It permits accurate response to load variation on plant. Because of the reduced number of components, the system is compact and costs less. The system is sensitive to moisture content in coal. High moisture content slows down the pulverizing process. It directly affects the air-fuel ratio in burner. Combustion of fuel. Next process that occurs in thermal power plant is combustion of fuel. It is essential that fuel burns completely. If not so, it will be wastage of money, and also we won't be able to get the maximum thermal energy from coal. Thirdly, it affects the environment adversely. All these factors make it essential that fuel burns completely. In modern thermal power plants, staged combustion of pulverized fuel is favored. This is because it provides low nitric oxide NOx emission. Low nitric oxide emission is essential for clean environment. Staged combustion. As is known, burner nozzle injects pulverized coal along with primary air. Radiant heat from outer portion of a flame and hot slag stuck to the furnace wall causes the ignition. The initial combustion thus occurring is known as primary combustion. Here, volatile matter in coal burns. Volatile matter in coal causes fast combustion. The zone where it occurs is known as primary combustion zone. Methane CH4, hydrogen H2 and carbon monoxide CO produced by primary combustion mix with surrounding oxygen O2 and form flame around particle of pulverized coal. Next, unburnt gases and char coming out of primary combustion zone are mixed with secondary air and burn. This forms secondary combustion zone. The combustion speed is reduced in this zone. Combustion time is around 10% in primary zone and around 90% in secondary zone. I conclude here the present lecture. In next lecture, I will take up the details of furnace providing staged combustion. Thanks for watching.